I welcome you all for a session on operating systems. What is an operating system? It is an interface between the users and the hardware. It also may be treated as an interface between users, hardware and an environment which is often treated to be the architecture. What does it enhance? It allows convenient usage. That is, it hides the tedious stuff from the user. Then it allows an efficient usage. That is, it enhances a parallel activity and it avoids wasted cycle. It provides information protection. It gives every user a slice of all the resources. It acts as a control program. These are the functionalities of an operating system. I repeat again, it is an interface that stays in between a user and a hardware or a user and an environment. It allows convenient usage. It hides the tedious stuff. It provides efficient usage in sense it provides us a parallel activity. It avoids wasted cycles. It provides information protection. And if there are n users in the entire environment, it provides every user with a slice of the available resource. And then by doing all this, it acts as a control program. So if you look at the operating system overview, it consists of human beings who are interfaced with program interfaces. You have a user program which sits on top of OS interface or the operating system interface, which is over an operating system. This operating system controls the hardware and interfaces. These hardwares and interfaces normally interact with the disk tapes or memory. Then what is an operating system? What is its mechanism? It is a mechanism which is used for scheduling of jobs or processes. Scheduling can be as simple as running the next process, or it can be relatively complex where it picks up rules to run a particular process. It also provides us with a method of simultaneous CPU execution and I/O handling, because in every execution we make use of the CPU and we like to have the I/O handled. This is done by an operating system. Processing is going on even as I/O is occurring, or is it in preparation for a future CPU work. This is what we do mean as a simultaneous activity. It can also be used for offline processing. That is, not only are I/O and CPU happening concurrently, but some self-board or off-board processing is occurring with the I/O. So these are some of your overview about operating systems. Here we need to understand something about multi-programming. We earlier told you that the wastage of CPU time is being utilized. That is, the CPU is wasted if a job waits for I/O. So what is that we can do to come across this? We can go for multi-programming. What is multi-programming? While one job waits for a resource, the CPU can be used for another job to make it run. It means that several jobs are ready to run and only one needs the CPU at a particular time. CPU scheduling is our subject of interest. All of this leads to memory management, resource scheduling and deadlock prevention. All these are taken care by an operating system. That is, it takes care of memory management, it takes care of resource scheduling, and it also takes care of deadlock prevention. The other characteristics of an operating system would include time sharing. It would also make use of distributed systems, where the loosely coupled systems that communicate via message passing. And the advantages include the resource sharing, speeding up of all your processes, reliability and communication. And finally, you can have real-time systems. These are systems which have rapid response time in operating systems as a major characteristic. It is used in control of applications where a rapid response to a stimulus is essential. Think about this. There were someone like a human being who comes to a class to take a lecture. He comes some 10 minutes late. What is going to be the effect? The class may become noisy. Other than that, nothing disastrous is going to happen. Imagine you are throwing yourself out of the window of an aircraft which is about to crash. You try to pull on your life jacket. It responds only after 10 minutes. What is going to happen? You may never be there to understand what has happened. So it would cost you a serious disaster. So wherever you have some systems which need rapid responses, you can make use of all these operating systems. Then you need to know something about interrupts and interrupts handling when you go for operating systems. Then how can you make it more efficient? If you are going to design a software, or if you are going to design an operating system which is going to be fast, you are trying to have something which is going to be more expensive. Very fast storage is very expensive. So the operating system manages a hierarchy of storage devices in order to make use of the best use of resources. In fact, a considerable effort has gone into this. The fast and expensive ones start at the register level. Something which are least fast and least expensive happen to be caches, main memory, electronic disks, magnetic disks, optical disks, and finally the magnetic tapes are those which are slow and can be affordable or cheap. So depending on the application, you can pick and choose between either fast and expensive or slow and cheap. The performance depends upon the amount of money you spend on it. Then caching is another important concept that we need to cover up in an operating system. What is caching? It is an important principle performed at many levels in a computer. Information in use is copied from slower to faster storage. A faster storage like a cache is checked first to determine whether if information is there. If it is, information used directly from the cache. If not, data is copied to the cache and is used from there. Cache smaller than the storage being cached. What is that we encounter now? The cache management needs to be an important design problem. Then the cache size and replacement policy are important while we consider this. We said memory management is an important concept that an operating system should take care of. What is memory? A user program can only access its own logical memory. For instance, it cannot modify a supervisor code. It depends on an address translation scheme such as a small structure which has been given in this picture. Then if you can recollect, the basic functions of your operating system happen to be memory management, time management, then you need to handle all your interrupts. You should properly have all your resources scheduled, and you should also try to have a deadlock protection. These are the various functionalities of an operating system.